Let's get started with making of a D-latch with synchronous reset. So we are typing the module here, then D-latch, D, inputs are D and giving a clock, then reset pulse we have, then Q. After that, input declarations, D, clock and reset. These are our inputs. Then we have output, Q, then register storing the values of Q, always block, making it from the behavioral modeling style, then clock or D. Then here we are giving a logic, that is if clock and reset, because we are making it synchronous reset, so clock and reset should be sync with the clock, and since it is level triggered, so we have to give this logic if clock and reset, then begin Q assigned to 0 and else statement, if clock, if there is only clock, then begin Q is assigned to D and ending the module and module. Writing the test bench for the D-latch synchronous reset, module D test, or we can say D-latch test bench, then register we have D, clock, reset pulse. After that, wire for the output Q, then D-latch, it's the module instantiation block, creating the objects of our code, D, clock, reset, Q. Initial, begin. Initial is here, we have used initial just to start our code. D equals to 0, initial values, giving the initial values. Clock equals to 0. Reset pulse we are giving after giving this initial value 0. Then $dump file, for our output waveform we are giving this test.vcd. This $dump file is used for printing of for showing of the output waveforms. Then $dump vars, hash those $200 finish. So after 200 seconds it will finish. the code. And always hash 3 seconds or 3 milliseconds, we can say that after 3 seconds or 3 milliseconds, we can say that RD will toggle always hash 5 clock to always has 12, giving a reset pulse that is toggling after this much of time. And module. Now our code has been completed. Now we are going to run it, selecting the simulators. Okay, test Verilog tools and simulators. We have this. Okay, then running it. This red mark, we can say it's the high impedance state is showing because we haven't given any initial value to the Q. So let's first get the setting the initial value of Q to 0. That is register Q equals to 0. So okay, then our high impedance state has been removed. So this is the output. We are giving a clock pulse. Here we have D, our input, that is Q, our output, and the reset pulse. See, we are actually dealing with the D-latch, so it's work on the level triggered of the clock. Our D is 1 here, and then 0, then it changes to 1. Similarly, up at this point, our Q also changes to 1, then it follows D. After that it follows D at 1, but when clock changes its level triggered to 0, then it holds its previous state, that is 1. After that, see, our reset pulse is high here, so this clock is also high here up to this level, so our reset will be high and our output will be 0 here. And in the next we see that at this level our D is 1, so our Q is also 1 because reset is 0. Similarly, this is the pattern of our waves and output waves following. So thank you guys, please like my video.